You might not know it, but misconceptions about the cause for the seasons are so common. So it's very important that we talk about it, especially because now you can actually understand why these seasons exist, because you now know so much about what the earth is doing, how the earth is moving, and what about its relationship to the rest of the sky. And so to start the discussion about the reason for the seasons, I have a question. Is earth closer to the sun in the summer and further from the sun in the winter? Is this true or false? Think about it. I'll give you a hint. Well, when it's summer in America, it is winter in Australia or South Africa for that matter. And you probably recall that America and Australia and South Africa, they're all on the same tiny little planet, which is very tiny compared to just how far away that planet is from the sun. So, I hope that hint was useful and demonstrative enough for you to realize that Earth is actually, that is false. That is not true that Earth is actually closer to the sun in the summer and further from the sun in the winter. It's actually the other way around. Just in case you didn't know, Earth closer to the sun in the winter. Which winter, you would say? The northern hemisphere winter, right? So Earth is going to be closer to the sun in the southern summer. All right? Okay, so basically seasons are opposite in the northern and the southern hemisphere. And so distance cannot be the reason. The real reason for seasons involves Earth's axis tilt. And here's a diagram that is going to hopefully help you better understand this, right? So here's the tilt of the axis, or what we mean by this, right? So this is the Earth revolving around the sun. All right, that happens for 12 months. All right, and remember that Earth that is rotating around its axis. It's revolving around its axis, but look at that axis. See, it's tilted relative to, say, the perpendicular to the plane in which the revolution of the Earth around the sun happens, right? And that tilt, that is 23.5 degrees. And so because that tilt is not changed, right? What happens is that during the winter, especially during the winter solstice, that's like the maximum of what can happen. Look, the sunlight, right? All those nice warm rays of sunlight, they fall almost grazing on the northern hemisphere, right? So this is north, this is south, right? While the incidence on the southern hemisphere is more direct, okay? Let's see what happens in the summer solstice. When it's really hot, we can feel all that sun way as in, hey, the northern hemisphere, right? See the sunlight? The sunlight comes more directly onto the surface of the northern hemisphere, and again more kind of grazingly on the southern hemisphere. So the seasons have a lot to do with how the direction of the sunlight is relative to the surface of the earth. Now, there is an applet on Mastering Astronomy, and whether I included that thing or not in the homework, and I hope I did, you should check it out, right? And think about it. Just think about, say, a bulb of light, right? if you let it on for even a few seconds, you know that it's not actually safe to touch it, so it spreads light and heat. And now put the hand like straight in front of it. Say you have something that directs that light coming from the bulb, right? So you can put the hand directly in front of the light source, or put it a bit to the side, and you can definitely feel the difference between how much heat is coming to those two situations, which is a lot more when the hand is straight in front of the source of the light. Also, make sure you check the applet for the seasons tutorials on the Mastering Astronomy. Again, if you still need some explanation as to why the tilt of the axis is actually the reason for the seasons on the of the Earth. All right, still not convinced? Here is how the distance between the Earth and the Sun looks like in the winter, right? So what do we have? 147.1 million kilometers, and here's in the summer. See, it's further away. Okay, but anyway, the difference, the variation in this distance is just about 3%, and that we can do the calculations. You can do it too if you really insist to. That only accounts for actually nothing. It's just so 3% variation in that distance is actually overwhelmed by the effect of the axis tilt. All right. Here's something nice that the ancient Greeks actually were the very first to think about, take note, put together as diagrams, write about it. This image here, it's called analemma, which in Greek means the pedestal of a sundial, and that is a curve of basically the changing angular offset of a celestial body, and in this case is the Sun, from its mean position on the celestial sphere as viewed from another celestial body, in this case is the Earth. So this is how we see the Sun during the year in different days, right? So this is actually the summer solstice, when the Sun is the highest in the sky, and this is where the Sun is lowest in the sky. So I think it's summer, that's June 21st or something, right? And here we have December 21st, close to that date. Okay, any guess what, kind of these 2 points, or actually a point here, would be? These are the equinoxes, the autumn or fall and spring. Okay, these are actually the points of intersection between the celestial equator and the ecliptic. They're very well defined by this motion of the Earth around the Sun. Okay, so yeah, pretty neat, isn't it? And in other words, and other ways by which you can recognize solstices and equinoxes is obviously by the Sun's path across the sky, right? So during the summer, actually at the summer solstice, which is the day, the longest day, the 24-hour period when the Sun is for the longest above the horizon. So again, this is the horizon. Okay, North Pole, South Pole on the surface of the Earth. So anywhere you are, you on the surface of the Earth, you will see something like that. So during the summer, the Sun rises very early, okay, and stays for many hours above the horizon, and then it's going to set. While in the winter, and it's also very high in the sky, and then in the winter is much lower. But again, all this true only for the northern hemisphere. Okay, if you decide to move, or you want to think about how it is to live and see all these things from the southern hemisphere, right, you are going to have to change some things. Okay, so for example, from the south, the highest path, okay, will be in the winter. Okay, that would be December, and it's going to be south, right? And then the winter becomes summer, December becomes June, and this becomes north. All right, okay, there you have it. And another note of caution, right? The four seasons, as you know it, as we know it, as we call them, right? They are actually characteristic of temperate latitudes only. All right, the seasons are actually much more extreme at high latitudes. For example, we have here the path of the sun on the summer solstice, that is the longest day, right? Or the longest 24-hour with daylight, and it turns out very close to the pole, right? That day is actually pretty long, almost 24 hours, right? If you consider that actually the sun never sets, it's always above the horizon, right? So you see, even at midnight, due north, right, the sun is still, it's just barely, it's very close to the horizon, still above the horizon, right? So actually, if you happen to travel, say, to Alaska, which is beautiful, in June, you will experience those really long days, right? I've been there in June, and I didn't feel like sleeping at all, maybe for an hour or so, and even that night was just not really night, it was just kind of like dusk. It was really a wonderful experience. All right, so also the tropics typically have rainy and dry seasons, so just two seasons, okay? And the rainy seasons are those when the sun is the higher in the sky, so kind of the equivalent of the summer. Also, another point of reference, right? During the equinoxes, the equator has the highest sun, right? So if you are to live in the Ecuador, for example, that's where you actually see the highest sun on your sky, right? On the Arctic Circle, sun still very low in the sky. All right, that's it about seasons.